Hello and welcome to our second pre-lesson for 8th grade math solving equations, or possibly 9th grade math, depending on the class you are in. It's a pre-lesson. Many of you may have seen this before in earlier grade levels, but just to remind us what to do. So today we're going to focus on two-step equations with integer coefficients. And then coming up, we are going to deal with two-step equations with fractions and decimals and what to do there. Okay, so today we are going to start with our notes, page 2 if you're in my class. And again, we're doing the same idea as we did yesterday. And the question you want to check with each of these is, does the problem have one type of variable? Meaning, does it have an x or a y, or are there multiple? Because if there's more than one, if there's an x and a y or an a and a b, we are going to solve it differently than I'm showing here. Does it have an equal sign? In order to solve it, it's got to have an equal sign. And then how do we solve it? We use inverse operations. And let me remind you that an inverse operation is an operation that undoes itself. So the inverse of add is subtract, and the inverse of multiply is divide, and vice versa. And there's more, but we are just focusing on those operations for this lesson. Okay, so let's get right into the example. So example 1 is a two-step equation. It's got one variable, here it is, the x, and it's got an equal sign. So just like if you watched the previous video, remember, we're imagining that our x is danger, right? And that all of our numbers are people, and our equal sign is a door, okay? And so if we're in the classroom, right, and this is our door, and this is danger of some sort, this x. The idea is, who's already safe? 15 is already safe. They're in the hallway. They're not going to come back into the classroom to the danger. So 2 and 3 are both in danger. Now, unlike yesterday, I'm going to rescue 2 people, quote unquote. I'm going to rescue the 2 and the 3. So the idea is this. The person, the 3 that is furthest away from danger, is most likely to exit first. And so what we want to do is focus on who's going to get out first. Well, the furthest away is this 3. So the inverse of the 3, the inverse of adding 3 would be to subtract 3. So if I subtract 3 here, I must subtract it on the outside, right? So I get 2x equal 15 minus 3 is 12. And then now I got to rescue the next number, okay? And so the 2 has to get out as well. Let me remind you that 2x in math means 2 times x. So to undo times 2, we would divide by 2. And we have to do that on both sides. This side cancels, and this side gives us the answer. 12 divided by 2 is 6. And that's our answer, okay? And so the idea is to undo all the operations, but you have to do it in order, because if you don't do it in the right order, then you're going to get an incorrect response. So what you're really doing is you're undoing Pemdas, right? So what we learn in early mathematics is we do parentheses first, then exponents, then multiply and divide are tied, and then add and subtract are tied. What we want to do is go backwards now to undo that. So we're going to undo adds and subtracts first. Then we're going to undo multiplies and divides. And then we'll get to exponents and parentheses later. Okay? So looking at this one, same idea. Negative 5x minus 2 equals 13. Okay, let's look. Who's already safe in this problem? 13, not coming back in, they're already safe. So we got to get out negative 5 and this minus 2, right? And so our choice is, who's going to get out first? Well, there's an add and subtract. We're going backwards. That's getting out first. Also notice that's furthest away from your danger, from your x. So we're going to start by adding 2 here and adding 2 here. So that gives me negative 5x equal positive 15. And again, it means multiply. So here's where students start to get a little confused. So am I undoing the negative 5 or am I undoing the multiply? In the second step, we're undoing the multiply. So since we're doing that, we're going to take the negative with us. We're going to divide by negative 5. We're going to take it with us. Cancel that and divide by negative 5. So we get x equal negative 3. A little rhyme that we kind of remember in my class is, if you multiply or divide, take the negative for a ride. So the negative's going to come with you. You're only undoing your minus and plus when you're adding and subtracting. When you multiply and divide, take that negative with you if it's there. Okay, this one's a little bit small, so I might have to rewrite it. Okay, so I can do that for those of you who can't see it very well. So this says y over 5 minus 12 equal 18. Okay, so again, look at this problem, and if this is danger, your y, your letter, right, then this is the door. 18 is already safe. Okay, so we're not going to worry about 18. We have to get out the 5 and the negative 12. Again, we're undoing Pemdas here, right? So is there an add or subtract that needs to get undone first? And the answer is yes, there's a minus 12. So to undo that, we will add 12 here to cancel and add 12 here. So now you have y over 5 equal 30. Okay, let's remind ourselves, what does the fraction mean? Y over 5 means division. So to rescue our 5, to get that guy out, we're going to multiply, because that's the opposite of dividing by 5. So that goes out, and we multiply by 5 over here. So your answer might be surprising. It's a large number. 30 times 5 is 150. And so that's our final answer here. And the reason it's large, right, is you've got a fraction in here. So 150 divided by 5 minus 12. Okay, you might want to double check that in your calculator if you're unsure, right? 150 divided by 5 minus 12. Does it equal 18? It sure does. We did it correctly. Okay, next one. So what's different about example 4, and again, I will write this larger, is that sometimes these two-step equations are written backwards, quote unquote, where your answer or your total is first. So this says 26 equal m over 6 plus 5. Okay, so just imagine, just like in a school, right? If this were a classroom, right, the hallway can be here. There's classrooms on both sides. So the the number that's already safe is 26 in this case. So they're not going back in. We got to rescue our 6 and our 5. So is there a add or subtract to undo? Yes, there is. We're going to start with that. So we are going to subtract 5, because that's the opposite of adding. So now I'm going to write this over here, but 26 minus 5 is 21 equal m over 6. Just like the example above, remember that means division. So to undo the divide, we will multiply by 6. That cancels. So 6 times 21 is going to give us our answer here, right? 6 times 21. And we get 126 equal m. And that's our answer. And again, you can double check that by putting it back in the original equation. Okay, last but not least is everyone's favorite, story problems. Okay, so the senior class is selling granola bars to earn money for prom. They purchased 1,250 granola bars and paid a delivery fee of $25. The total cost, including delivery, was $800. How much was each granola bar? What would be a good amount to sell them for? Okay, so when doing story problems, you want to make sure that you identify your most important information. So 1,250 granola bars and a delivery fee of $25 and a total was 800. Okay, the word total tells me that it's going to equal 800. And I know I'm going to use my 1,250 granola bars, and my 25 here. The question is, which one of these should get our variable, okay? And so let's think about this. $25 was a set cost. That was the delivery fee. What we're trying to figure out is if we paid if we bought 1,250 granola bars, how much was it for each? So our variable goes on here. And we added our $25 all together. It was $800. So here's your equation, and it looks like the ones we've been working on, right? And so in this case, our 800 is safe, right? So is there an add or subtract to undo? Well, there certainly is. We're going to undo our plus 25 by subtracting. Okay? And so now I have 1250G equals 775. And now this looks weird, right? But 1250 times G, we're going to undo that by dividing. And you might be saying, Mrs. Richards, that's going to give me a decimal. I want to remind you that we're working with money, though, okay? So 775 divided by 1250 gives me 0.62, and that's okay because our granola bars that we're paying for in dollars, that means that they were 62 cents each from the company. So that's part of our answer, right? The other part it's asking us is what would be a good amount to sell them for, because they're trying to raise money. So if you were trying to raise money and you paid 62 cents each, maybe you want to sell them for $1 each, okay? That way, you make some money off of them, and it's worth it for the fundraiser. Maybe even sell them for $2 each if you think that's what people are willing to pay. Okay, so that's it for two-step equations. Hopefully you found that helpful. If you're in my class, we're doing side 2 of the worksheet I handed out yesterday with the two-step equations. And next up will be multi-step. Hopefully this is helpful before our big lessons with fractions and decimals.